Everyone, welcome back to another video, and today we're going to be starting with Cambridge IGCSE Chemistry Paper 4 Theory Extended October-November 2024, Paper 44. If you guys are O-level student, this paper is really going to be helpful for you because after the recent syllabus updates, the O-level and IGCSE syllabus is exactly the same. And these IGCSE papers, they are a really good help for the O-level students, and they help you practice the syllabus more. So this is going to be a great practice for the O-level student as well, okay? So let's start with the first question. The formula of the molecules A to I are shown in table 1.1. Okay, this is the table and we have formula of some molecules. Okay, this is alkene. Okay, C2H4, you should write it. This one's alkene. This one C2H5OH is ethanol. Okay, you can write it beforehand, so when you're answering the questions, you're sure. ठीक है, CO. When we have a single oxygen with carbon, one means mono. ठीक है, one means mono. So it's gonna be carbon monoxide, which means we have a single oxygen with carbon. So it's gonna be carbon monoxide. You can write it this way, so it's more helpful and you're more sure about your answers. This one, we have two oxygens with carbon, so it's gonna be carbon dioxide. Okay, the next one is simple chlorine gas, Cl2. So we can write chlorine. The next one is nitrogen dioxide. When we have two oxygen, we write dioxide. The next one is simple nitrogen gas. And the next is oxygen. And then we have sulfur dioxide. So we are done with all the pre-work we have to do in order to solve the questions. Let's start. Answer the following questions about the molecules A to I. Each letter may be used once, more than once, or not at all. State which of the molecule A to I is an element with a triple bond. Okay, so you guys should know that the triple bond is formed in nitrogen. Okay, this is a very important thing to know, that N2 means that you have two nitrogen molecules, something like this. This is also an N and this is also an N. And N2 means that there's a triple bond between these two nitrogen molecules. Over here, these three lines represent a triple bond. Okay, so nitrogen is in group 4, so it group 5, so it has 5 electrons in its outermost shell. 1, 2, 3, 4 and 5. Now nitrogen needs 3 more in order to have complete outermost shell. So nitrogen is going to make 3 covalent bonds. Okay? So what nitrogen does is it basically makes 3 covalent bonds. So this is the first bond, this one is the second bond, and this right here is the third bond. Okay, so these 3 electrons belong to this nitrogen, these crosses one, and these dots belong to this nitrogen. Okay? So now one nitrogen has used its 3 electrons in covalent bonding. Nitrogen has 5 in its outermost shell. So how many are left? 2 electrons are still left. These crosses and these dots. So this is basically N2. So we're gonna write, it's gonna be N2. Is a product of photosynthesis. You should know that photosynthesis is basically when carbon dioxide and water combine in the presence of sunlight to form glucose and oxygen gas. So we have oxygen gas over here, so we're gonna write O2. The next question is used as a fuel. You guys should know that we use ethanol as a fuel. Okay? Ethanol is widely used as a fuel, so it is gonna be B. I'm writing the chemical formula over here, but you guys write A, B, C, and that's gonna be better. I'm writing so that it's more clear. Okay? But for the question, you guys gotta write, for nitrogen, you have to write G. For is a product of photosynthesis, that is oxygen. For that you write H. And for C2H5OH, which is ethanol, you write B. Okay, turns lime water milky. You should know the test for carbon dioxide gas that returns lime water milky. So it is going to be this carbon dioxide gas, which is going to be D. So this one's D. The next is undergoes a substitution reaction with alkanes. What undergoes a substitution reaction with alkanes? Do you guys remember that we used to take alkanes and then we used to, react it with chlorine, and it would form dichloro or dichloroethane? Remember? Dichloroethane. What we used to do is, let me show it to you guys. We got to take an alkane, something like this, and we had all hydrogens on the sides, and then we used chlorine for substitution reaction plus Cl and Cl, and chlorine would substitute one of the hydrogens from here and forms and bond over here and H over here. So that were the products. So we use chlorine for the substitution reaction. Chlorine, Cl2, and well, that's gonna be E. Okay. Is a colorless liquid at RTP? Let's check out what is a colorless liquid. Sulfur dioxide is a gas, oxygen is a gas, nitrogen is a gas, this is also a gas, gas. This one is also a gas. Okay, the smaller alkenes are gas, so it is gonna be B or ethanol. Okay, because ethanol is a liquid. Next one is unsaturated. Unsaturated means it's going to be an alkene and it should have carbon-carbon double bonds. So for alkene we have C2H4, that's going to be A. Okay, next one is 21% of clean dry air. You should know that oxygen is the gas that makes up 21% of the clean dry air. Well, that's going to be part H. Okay, oxygen is H. Let's move on to the next question, which next part, which says, is the reaction in the Haber process, a reactant in the Haber process? You should know that nitrogen and hydrogen react in the Haber process. N2 plus 3H2 form N2NH3. So that is going to be nitrogen gas, which is G. Okay, so here we are done with the first question. Let's move on to the next. Aluminium is manufactured by the electrolysis of aluminium oxide. State the name of the main ore of aluminium. So the name of this ore is bauxite. We use bauxite to extract aluminium. Okay? Name the substance mixed with aluminium oxide to reduce the operating temperature of the process. The substance we mix is known as cryolite. Okay? Cryolite. And this substance basically reduces the cost for a high temperature. It causes aluminium to stay molten at a low temperature, so it reduces energy costs. Explain why molten mixture in B conducts electricity. The molten mixture in B is basically aluminium oxide, Al2O3 plus cryolite. Take care. So it conducts electricity because it has free aluminium and oxide ions. Because it has free mobile ions. Mobile means that they are able to move. It has free mobile ions to move through the structure and conduct electricity. Let's move on to the next question, which says table 2.1 contains some information about the processes which take place at the anode and at the cathode. Okay, here we are given with the reaction at the anode and we have to reduce the reaction at the cathode by ourselves, I guess. Okay, write the number of electrons needed to balance the ionic half equation for the reaction of the anode. Okay, so look over here. We know that one oxygen has a charge of 2 negative, which means that it gains 2 electrons. Over here, we have 2 oxygen with a charge of 2 negative. If one oxygen has a charge of 2 negative, then 2 oxygen means that we have negative 2 and negative 2 electrons, which means we have negative 4 electrons. Okay? 2 oxygen means that we're going to have 4 electrons, so it's going to be 4 electrons. And at the cathode, obviously if at the anode we're getting oxygen from bauxite, which is Al2O3, at the anode we're going to get aluminium, so Al3 plus, so we're going to add 3 electrons to it and we're going to form aluminium, which is going to be Al. Let's move on to the next question. Write the ionic half equation for the reaction of the cathode. We're done with these two. Let's move on. State why the process at the anode is an oxidation. Look, oxidation is loss of electrons. Okay? Oxidation is loss of Electrons. Okay, what is happening with oxygen? This is oxide ion. Okay, the oxide ion is losing 4 electrons to form oxygen. Okay, this is an oxide ion and it is losing 4 electrons. Okay, plus 4 electrons means that it loses these 4 electrons to form oxygen gas. So state why the process at the anode is an oxidation. Oxide ions, okay, these are the oxide ions. Oxide ions are losing electrons. So that's going to be the reason for oxidation, because oxidation is basically loss of electrons. Oxygen is formed at the anode. Explain why the main gas given off at the anode is carbon dioxide and not oxygen. The reason for that's very simple, because let me tell you guys, when you form oxygen, what happens is that this oxygen reacts with the carbon. Okay, the anode is made up of graphite. Okay, the anode is made up of graphite and graphite is carbon. So the oxygen formed at the anode reacts with the carbon in the graphite. Okay, this is basically your anode. The oxygen that's formed reacts with the anode to form carbon dioxide gas. So we're going to write that anode is made up of graphite, which is carbon, of graphite, which is carbon. So the oxygen gas formed reacts with the carbon to form carbon dioxide. Okay? To form CO2 gas. Okay, state why aluminium is used in food containers. Okay, so I'm gonna tell you this thing, that if this is aluminium, aluminium basically has a layer of aluminium oxide on it. Okay, with red I am drawing the layer of aluminium oxide. I don't know why it just erased. Let me draw it again for you guys. With red now I'm drawing the layer of aluminium oxide. So basically this layer of aluminium oxide, which is Al2O3, is resistant to corrosion. It does not allow aluminium to corrode. That's why we use aluminium in food containers, because of its apparent lack of reactivity. Why? Because aluminium is very reactive. This aluminium metal is very reactive. But what is not reactive is this layer of aluminium oxide, which is formed at the top of aluminium. Okay, it does not allow the air and water to get inside and react with aluminium. So we use aluminium in food containers because of its property of lack of corrosion. You can write due to a layer of aluminium oxide on it. Okay, let's move on to the next question, which says aluminium reacts with chlorine to form an ionic compound, aluminium fluoride. Complete the dot and cross diagram in figure 2.1 of the ions in aluminium fluoride. Give the charges on the ions. Okay, before writing down the ions, the electrons, you should know that aluminium always has a charge of 3 plus and fluoride always has a charge of 1 negative. Okay, now we're gonna check out the atomic numbers of aluminium and fluorine in the periodic table. Okay, so that we know how many shells we have to draw. Okay, let's check out for aluminium first. So aluminium is 13, so this means that we have to draw a total of 13 electrons, because this is the proton number that we have circled and the proton number and the electron number is the same, but we have to draw an ion. So I'll tell you what we'll do, but first we have to figure out for fluorine. For fluorine it's 9. Okay, now let's move and draw the ions. I'll tell you what to do with ions. Okay, aluminium had, in the periodic table we got to know that aluminium has 13 electrons. Okay, but the problem is that it has a charge of 3 plus. 3 plus charge means that 3 less electrons. ठीक है, 3 plus charge means 3 less electrons. That means that we're going to subtract 3 from it and we are going to get 10. So we have to draw 10 electrons. Why? Because we have an ion. For an ion, we cannot have equal number of protons and electrons. ठीक है, for fluorine we had 9 in the periodic table, but over here we have a charge of -1. -1 means that one more electron than proton. ठीक है, one more electron than proton. So 9 was the proton number, so electron number is going to be +1. We have to take one more electron because we have a -1 charge. That's going to be 10 electrons. ठीक है. Okay, so let's draw the 10 electrons for aluminum first. We already are given with the 2 electrons. This means we only have to draw 8 more. ठीक है. So we're going to draw this shell over here, and that's going to be 1, 2, 3, 4, 5, 6, 7, and 8. Here we go. Now we have to draw 10 electrons for fluorine as well. 1, 2, 3, 4, 5, 6, 7, 8. We already have these two, so we only need 8 more. So for this as well, we're going to write 1 negative, 1 negative. One important thing, that instead of writing +3, it's better if you write 3 plus. ठीक है, that looks better. That's just a humble advice. ठीक है. Now 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. ठीक है, done with it. Let's move on to the next question. Sulphur forms 2 chloride P and Q. Chloride P has the formula S2Cl2. Chloride Q has the formula SCl2. Both chlorides are covalently bonded and have low melting points. Suggest in terms of attraction between particles why these chlorides have low melting points. Obviously, the attraction between the particles is going to be less. That's why there are weak intermolecular forces of attraction holding them together. ठीक है, in terms of attraction means that we have to write our answer. In terms of attraction mean we have to include the word attraction in our answer. ठीक है. So between particles, so the attraction between particles is going to be less and it's going to have weak intermolecular forces. So we can phrase our answer like, there are weak intermolecular forces of attraction. There are weak intermolecular forces of attraction holding the molecules which ठीक है, need high amount of heat which need less amount of heat energy, to be overcome. ठीक है, that's why it has low melting and boiling point energy to be overcome. ठीक है, let's move on to the next question, which says chloride PS2Cl2 forms when sulfur reacts with chlorine. Write the symbol equation for the reaction. ठीक है, we simply have to react sulfur, which is S, plus Cl2 to form S2Cl2. We got a balance and we have 2 sulfurs here, so we're going to write a 2 over here as well. ठीक है, let's move on to the next question, which says complete the dot cross diagram in figure 3.1 of a molecule of chloride Q SCl2. Show the outer electrons only. ठीक है, so one thing I gotta tell you, sulfur is in group 6. ठीक है, 6 group means that it will have 6 electrons in its outermost shell and it only needs 2 more electrons. ठीक है, sulfur only needs 2 more electrons. What did I just tell you? Sulfur only needs 2 more electrons, so it is going to make 2 covalent bonds, one over here and one over here. Now next thing is that chlorine is in group 7, which means that chlorine only need 1 more electron, so it is only going to make 1 covalent bond. Okay, so now let's make covalent bonds. For chlorine, 1 over here, and for chlorine other, 1 over here. Now sulfur has 6, and this dot belongs to the sulfur and cross belongs to the chlorine. So sulfur has used 2 out of the 6 electrons it had in its outermost shell. 2 are used, so now it's only going to have 4 left. 1 2 3 4. Chlorine had 7. It has used 1 in the covalent bond. Now it is left with 6. So we're going to make 1 2 3 4 and 5 6, and 6 on this side. 1 2 3 4 and 5 6. Let's move on to the next question, which says chloride P is converted into chloride Q by the reaction with chlorine in a closed system. The reversible reaction reaches an equilibrium. The forward reaction is exothermic. Okay, so one thing over here is that the forward reaction, which is this reaction, is exothermic. I'm writing exo. Whenever they tell you that the forward reaction is exothermic, always remember that the backward reaction is going to be endothermic. And when they tell you that the forward reaction is endothermic, the backward is exothermic. So in reversible reaction, if the forward reaction is exo, the backward is going to be endo. And if the forward is endo, the backward is going to be exo, because they're always reverse of each other. Okay. Suggest 2 changes to the conditions which will result in a decrease in the concentration of chloride Q. So this one right here, we have chloride Q, and we need to decrease its concentration, which will result in a decrease in the concentration of chloride Q at the equilibrium. Okay. So what we will do is that, look, I'll explain it to you guys. We are forming chloride Q because of exo reaction. Look, to reduce the temperature, if we for example, if we heat it, okay, if we heat the mixture, what will happen is we need more of the reactants, okay. We need to decrease the concentration of 2SCl2, okay. We need to decrease its concentration, okay. We need to decrease. So what we will do is we will give it heat. And what will heat do? Heat means that less of exo will happen and more of endo reaction will happen. So the equilibrium will shift towards the reactant side, because forward reaction is exothermic. So if we heat it, you remember when we give heat to exothermic reactions, what happens? The equilibrium shifts towards the endo sides, because endo means that whatever we try to do, the equilibrium tries to reverse it or balance it out. Okay? For example, if you will increase the pressure, the equilibrium will do something which balances out. Okay? If you increase the temperature, what will equilibrium do? It will do the endo reaction. So that temperature is again comes to normal. So what will happen? It will shift towards the product side, towards the reactant side, and less chloride Q is going to be formed. So we can increase the temperature so that this concentration decreases and the concentration of chloride P increases. So the one thing we can do is increase temperature. And second thing we can do is, look, what will happen is if we remove any one of the reactants, the equilibrium will try to balance it out and produce more reactants. Okay? Let me repeat my step. Whatever we do, equilibrium tries to balance it out, to reverse whatever we do. So if we remove the reactants, I take out the chlorine, equilibrium will move towards this side and produce more of chlorine and S2Cl2 and less of Q. And that's what we want. We want to reduce the amount of chloride Q. So what we're going to do is we are going to remove the reactants. So the equilibrium shifts toward this side and produces more reactants. So what we can do is we can remove some Cl2 and the other reactant is S2Cl2. And what will this do? Shift the equilibrium towards this side. What we really want is more of the reactant to form and less of chloride Q to form. Let's move on to the next question, which says the rate of the forward reaction in D is determined by the collision theory. The rate of the reaction depends upon 2 factors: the frequency of collisions between the particles and the proportion of the collisions with which have energy greater than or equal to the activation energy. Define term activation energy. Okay, so activation energy is the minimum amount of energy. It is the minimum amount of energy which the reactant particles, minimum amount of energy which reactant particles must have, in order to react. ठीक है, particles must have in order to react. ठीक है, let's move on to the next question, which says give the symbol for the activation energy. You should know this. This is quite easy. You write an E and below it you write a small a. This is the symbol for activation energy. Let's move on. Complete table 3.1. Show the effect, if any, when the conditions are changed. Use only the words. Okay, we can only use these words in the table: increases, decreases, or no change. Okay, let's see the table. Okay, so for table, the change to condition number 1 changes: concentration of chlorine is increased. ठीक है, effect on the frequency of collisions between particles. Okay, so if you're increasing the concentration, which means that we are having more particles. ठीक है, if this is our container, we're increasing the concentration, we're going to have more particles. So the frequency of collisions between the particles also increases. ठीक है, let's move on to the next. Effect on the proportion of collisions which have energy greater than or equal to the activation energy. Basically, by increasing the concentration, we are not increasing the energy. ठीक है, by increasing the concentration, we are not increasing the energy of the particles. So we're going to have no change. Okay, for temperature is increased. Next is temperature. So obviously when temperature is increased, the frequency of collisions will increase because the energy of the particles increases and particles move faster. So it is going to be increases. Next is effect on the proportion of collisions which have energy greater than or equal to the activation energy. Obviously when we increase temperature, we give particles more energy. So more particles will have energy equal to or greater than activation energy. So it is also going to increases. It also increases. Okay, a catalyst is added. When a catalyst is added, what catalyst does is it lowers the effect of a catalyst is it lowers the activation energy, EA. ठीक है, so when the activation energy is lowered, so the proportion of collisions which have energy greater than or equal to activation energy will increase. Why? Because there will be more proportion of collisions. The collisions will increase which have activation energy because the activation energy is lowered now. There is less amount of energy that the particles need to collide, so what will happen is that the frequency of collisions will also increase and more particles will have energy equal to activation energy. Let's move on to the next question, which says the reaction of chloride P with chlorine is a redox reaction. ठीक है, this is chloride P and it is a redox reaction. The oxidation number of chlorine in chloride P and chloride Q is -1. Use oxidation numbers to explain why sulfur is oxidized in the forward reaction. ठीक है, this is the forward reaction and they're saying that sulfur is oxidized. Oxidation is loss of electrons. ठीक है, remember reduction is always gain of electrons and oxidation is loss of electrons. ठीक है, so we are basically losing electrons. Let's see how chlorine is losing electron. That means the oxidation state of chlorine will change. Let's figure out the oxidation of state of chlorine and first this. What is the oxidation state? देखें, Cl2, one chlorine is gonna be, one chlorine is -1 and we have 2 chlorines, so it's gonna be -2, the total charge. To balance out -2 charge, we need a +2 charge. So 2 sulfurs have a charge of +2. ठीक है, 2 sulfurs have a charge of +2. So obviously one sulfur will have a charge of +1 now. देखें, if one person has a banana and one person also has a banana, so 2 persons have 2 bananas. ठीक है, 2 persons have 2 bananas, so 1 person will have 1 banana ना. That's easy. अगर 2 sulfur के पास, if 2 sulfur have 2 plus charge, this means 1 sulfur has +1 charge, and when both of their charges added +1, that is gonna make +2. ठीक है, over here what is 1 chlorine is -1 and we have 2 chlorine, so it's -2, And to balance out -2, we need a +2, and one sulfur has +2. So, well, that is oxidation, because over here, sulfur has moved from a charge of +1 over here to +2 over here, which is an increase in oxidation number. So, this is going to be oxidation number. Sulfur is oxidized in the forward reaction. Use oxidation numbers, okay? So we are gonna write that obviously there is an increase in the oxidation number, okay? The oxidation number of sulfur increases from +1 to +2, okay? Chlorine is oxidized in the reverse reaction. Let's check out, okay? So for that, I'm erasing all this which we have done. In the reverse reaction, chlorine is oxidized. Okay, so over here, the charge on chlorine is a 0, okay, because it is in elemental form, and over here it is a -1. We just calculated it out. Otherwise, for chlorine, you don't need to, calculate the charge. You should know that chlorine is always going to be a -1. Okay, oxygen, chlorine, these are some kind of elements that we know. So from 0 to -1, it's... No, wait a sec. I'm so sorry. Okay, this is 0 and this is -1, and over here it's also -1. Okay, so what do you guys think? How is chlorine oxidized? This is the reaction. This is 0, this is -1, and this is also -1. Basically, from -1, chlorine is going to 0. We are not going to consider this -1. Why we are not going to consider it? Because over here, the oxidation state of chlorine has not changed. From -1, it remains -1. So we are not going to consider this one. We're only interested in the one that has been either oxidized or reduced. And well, this is an oxidation, because this is an increase in oxidation number from -1 to 0. So we are going to write that chlorine has been oxidized because the oxidation number increased -1 to 0. Let's move on. Okay, so I'm just giving you 1 minute to just read all this, so then we can continue. Okay, so here we are forming a salt. If you guys have read it, you should know that we are forming a salt. Okay, this is the equation we are given it. We adding 200 cm cube of this. This is the volume. Just write it over the things, because that's going to help you calculate moles. This is the concentration. The volume contains these many moles. These are the moles of Ag plus ions. Okay, add 50 cm cube, just underline it, that's volume of NaBr, and these are the moles. Okay, then we filter the mixture, dry the solid residue until all the water is removed, record the mass of the dry residue, and complete the ionic equation for the reaction. Okay, you should know that silver ethonate. What do you think? Is silver ethonate soluble? I'm writing a solubility rule over here that all ethonates are soluble. Almost all ethonates, not all. I'm gonna say that almost all ethonates. I'm gonna add in almost all ethonates are soluble. Okay, so that is gonna be that this ethonate, which is silver ethonate, is soluble. So in front of silver ion, you're gonna write AQ. For soluble salts, we write AQ. Is sodium bromide soluble? all sodium salts are soluble. Okay, all group 1 metal salts are soluble. So all sodium salts are soluble, and hence we're gonna write AQ over here. AgBr, this is insoluble. Silver bromide and lead bromide are insoluble, so you're gonna write a solid over here, S. Okay. Name a different aqueous silver salt which could be used in step 1. Okay. For step 1, what we need is, we have taken a silver ethonate, which is a soluble salt. The requirement is basically that the whichever salt we take should be soluble. Why? Because whenever, remember, in precipitation method, when we are making an insoluble salt, okay, we have to take 2 soluble salts, and that then makes an insoluble salt. Okay, we are making silver bromide, which is insoluble, so for that we need to take 2 soluble salts. So if we take any other salt than silver ethonate, we need to make sure that it's soluble, because for precipitation method, you remember, we take 2 soluble salts to make an insoluble, so this has to be soluble. So if we are taking any other silver salt except for silver ethonate, it can be silver nitrate, because it has to be soluble. Some of you might think that it can be silver sulfate, but silver sulfate is partially soluble, it's not fully soluble. So don't write silver sulfate because it is not fully soluble. Okay, use the information step 2 to calculate the concentration of aqueous NaBr. Okay, step 2, this is the volume and these are the moles. Okay, I'm gonna write the volume is 50 cm cube and the moles of Br negative is 0. This is Br negative, the moles are 0.01. Okay. Now why this is so, now how are we going to calculate the concentration of NaBr? We're going to make it moles over volume, and that is concentration. Now you might think that this is the concentration of NaBr, so why are we only taking the moles of Br? Because the moles of Br will be equal to the moles of NaBr, because in 1 mole of NaBr we have 1 mole of Br. Okay, if for instance I write a 1 over here, that means I have 1 mole of sodium and 1 mole of Br. Okay, in 1 mole of NaBr we have 1 mole of sodium and we have 1 mole of Br. So 1 mole of Br means that we have 1 mole of NaBr. That's going to be the same value. So it's going to be 0.01 over 50 divided by 1000. Why? Because it's in cm cube and we always take concentration in dm cube. 1, 2, 3, 0.05. Just put it on your calculators. 0.01 divided by 0.05. Well, that's gonna give you 0.2 mole per dm cube. Okay, let's move on. State the color of the precipitate which forms in step 2. So which precipitate is forming in step 2? Don't you think bromide precipitate is forming? Or bromide ions, a precipitate forms. The precipitate is going to be bromide. The bromide precipitate is, the color is cream. Remember that for iodine, for chloride, the precipitate color is white. For bromide, it's cream. For chlorine, bromine, for iodine, it's yellow. Okay, remember these 3 precipitate colors. Let's move on. Use the information in step 1, step 2 and equation 1 to determine the number of moles of AgBr formed. Use this value to calculate the mass of AgBr formed. Okay, now we have to use the information in step 1, step 2 and equation 1 to determine the number of moles of AgBr formed. Number of moles of AgBr formed. Okay, let's move on. We have to calculate the moles of this compound. Okay, what we have is that we know the moles of our 0.01 mole of NaBr. Okay, how do we know? Because the moles of Br equal to the moles of NaBr. Okay, so we have 0.01 moles of NaBr. Now look at the mole ratio. Okay, I'm gonna erase all other things so you can easily see the mole ratio. Now look at the mole ratio. Okay, 1 mole of NaBr forms 1 mole of AgBr. So the mole ratio is 1:1. 1:1. So 0.01 moles of NaBr are going to form 0.01 moles of AgBr. So what's going to be the answer? Moles of AgBr are going to be 0.01. Okay, now we have to calculate the mass of AgBr. The formula for mass is equals to moles into mr. What is the mr of AgBr? For that we got to consult the periodic table. For we need the mass for Ag and Br. So for Br it's gonna be 80. Let's circle it out here. For Br it's gonna be 80, and for Ag it's probably gonna be, let's search it out, 108. So it is 108 plus 80. 108 plus 80, and that's gonna give us 108 plus 80, and that is gonna give you 188. So what we're gonna do is we're gonna multiply our moles with 188. Moles is 0.01 multiplied by 188, and that's gonna give you the 1.88. The mass is gonna be 1.88 grams. Okay. If there's a calculation error, I'm sorry. Just calculate it on your calculators. This procedure is correct. Okay, name the salt dissolved in the filtrate in step 3. The salt that is dissolved in the filtrate. Okay, now we are forming two salts over here. AgBr is insoluble, and the other form, which salt which is formed, which is sodium ethanoate, is soluble. So we are gonna write, we have to write the name, we don't have to give the symbol. So we are gonna write, it's gonna be sodium ethanoate. Okay. Okay, the recorded mass of the residue in step 5 is greater than the mass calculated in E because a step is missing from the procedure. Missing step. Okay. So the missing step is gonna be that guys didn't wash your precipitate. After filter the mixture, after filtering it and getting the precipitate, you always wash your precipitate with distilled water. Why do you wash your precipitate? Because all the soluble impurities, when you get the precipitate from this mixture, okay, two salts are formed. One salt is going to be AgBr, that's going to be the precipitate, and there's going to be another soluble salt, which is sodium ethanoate. So some of sodium ethanoate might be on the precipitate. So you wash the precipitate with cold distilled water. Otherwise, that sodium ethanoate is going to crystallize on your salt if you dry it without washing. So what has happened here is that you didn't wash the salt and you dried the solid residue until all the water is removed. You dried it without washing, and when you don't wash the salt, you have other soluble impurities like sodium ethanoate. So that's gonna be that you forgot to wash the precipitate with distilled water. Okay, that's why there's an increase in mass. Why? Because there is mass of other things like sodium ethanoate, because sodium ethanoate was dissolved in it. So you had to wash the precipitate. Suggest the missing step, that's going to be wash the precipitate. Okay, the next is name a substance that is responsible for the greater mass of the dry residue. What is responsible? Sodium ethanoate. Why? Because sodium ethanoate is on the precipitate. If you don't wash it, you cannot remove sodium ethanoate. That's why you wash it with distilled water. Okay, wash the precipitate with distilled water. Okay, let's move on to the next question, which says barium sulfate can be made by the same method but with different aqueous solution. Okay, barium sulfate is also an insoluble salt, and in order to make an insoluble salt, you take two soluble salts. Okay, so just two aqueous solutions which can be added together to make barium sulfate. They both got to be soluble. So one you can take is barium nitrate, that is also soluble because all nitrates are soluble. Another you can take is sodium sulfate because all sodium salts are also soluble. Next is write a balanced symbol equation for this reaction. Okay, so you got to take barium nitrate NO3, you added 2 over here because barium is +2 and NO3 is -1. Barium nitrate plus sodium sulfate, you're going to take 2 sodiums. Why? Because sulfate is -2. Okay, so and sodium is +1, so it's going to be 2 sodiums, and that's going to make you sodium nitrate NaNO3 plus barium sulfate and you balanced it by writing it 2 over here. Okay, here you form barium sulfate. Let's move on, which says alkenes are manufactured by cracking large alkane molecules. State the source of large alkane molecules. Where do you get large alkane molecules? Where do you get all of this? You get all of this by petroleum. Okay, when you basically dig out petroleum from underground, and then you get the large alkane molecules and then you crack them. State 2 conditions needed for cracking. Okay, when you crack, first you need a catalyst. That's for sure. That is, you can write Al2O3 or SiO2. Okay, and other is you need an extremely high temperature for cracking. Okay, next is when one molecule of decane C12H26 is cracked, three molecules of but1ene and one other product is formed. Use the molecular formulae to complete the simple equation. Okay, we have to form. Okay, but1ene simply means that we're taking butene. Okay, this one has nothing to do with the simple written the written formula. But1 is going to be C4H8. Okay, simple C4H8 butene. Okay, but means 4 carbons. So what we're going to do is we have to form 3 molecules of C4H8. Now calculate, because the number of carbon and hydrogen on this side of the equation needs to be balanced with the number of carbon and hydrogen on this side of the balance. On that basis we form product. So over here 3 times 4 is 12 and 3 times 2 is 24. So the carbon over here and here are complete, so we cannot add any more carbon in the next product. However, we have 24 hydrogen over here and we need 26. So what we can make is we can make hydrogen gas, which is H2, and now the number of carbon and hydrogen are fully balanced. Suggest the type of chemical reaction which happens during cracking. Okay, what in cracking you are doing is you are taking a large chain hydrocarbon and you are decomposing it into small chain hydrocarbons. Okay, C4H8 is a small chain hydrocarbon. You are taking a large molecule by using high temperature. You are breaking it down. So that's going to be thermal decomposition. Why? Because you're breaking it down into small molecules by using heat. Okay, next is propene, which is an alkene, will undergo polymerization. Suggest the name of the polymer formed from propene. Whenever you need to form a polymer, just write down poly in front of the monomer. So poly, the monomer is propene. The monomer is basically the small units from which the polymer is formed. So it's going to be polypropene. Draw the part of this polymer molecule to show 3 repeat units. Okay, so let's first draw one propene. Propene is going to be 3 carbons and hydrogen 1, 2, 3, 4, 5 and 6. This is going to be a propene molecule. Now we are going to write it in standard form. What does standard form mean? That we need this carbon, double bonded carbon in the center and all the rest of these things on the sides of the carbon. We don't want this. When we need to do polymerization, we need to shift this this part of the molecule, this part at the bottom, okay? At the bottom of this carbon, okay? Let me show you how I'm going to do this. I'm going to take this carbon, add the hydrogen over here, and instead of this CH and H, I'm going to write CH3. Okay, that's going to be simple CH3, double bonded C, this H over here and this H over here. Now this is my monomer. Why I wrote this propene in this form? Because now I can easily polymerize it in this form. When I have C and C on both sides, over here I cannot polymerize it easily because I have this C single bonded C, and it will create difficult when once I polymerize it. So I shifted this thing downwards over here. Now what I'm going to do is I have to draw 3 repeat units. So I'm just going to I'm just gonna draw my first repeat unit, which is now I have to break this double bond. So H, CH3, H and H. This is my first repeat unit. Now here comes, I'm gonna erase my this as well because I don't want examiner to see this. Why I don't want examiner? Because examiner might consider this as my answer. Now I'm gonna draw the second repeat unit, which is gonna be H, CH3, H and H, and now I'm going to draw my third repeat unit, which is H, CH3, C, HN, H, and I'm going to extend the bonds. I'm going to draw these things around it, and here I go with my 3 repeat units. This one is my first repeat unit, this one is my second repeat unit, this one is my third repeat unit. And the first thing I did was I drew the structure of my monomer. Okay, I brought my monomer into my standard form. And so what is the standard form? C double bonded carbon to carbon should be in the center, and then I broke the double bond and joined them. Okay, state the type of polymerization propene undergoes. Alkenes always undergo addition polymerization, so it's going to be addition polymerization. Okay, let's move on to the next question, which says that polyamides and polyesters are polymers. Polyamides can occur naturally or can be manufactured. Part of the structure of a polyamide is shown in figure 6.1. In figure 6.1, draw a circle around one amide linkage. Okay, so I'm going to draw a circle around a bunch of amide linkage. This black one is one molecule, and this white one is one molecule. Then we have a black. Okay, I'm going to color code it so that it's easier for you guys to see. I'm going to outline all the black boxes with the green color. Okay, and I am gonna color code all the white boxes with a blue color. Okay, so now you have a pattern of green, blue, and green. So these green and blue boxes are joined together by amide linkages. So you can take any one amide linkage. This is an amide linkage where you have joined them. Then this is an amide linkage where you have joined them. This is also an amide linkage where you have joined the boxes, and this one is also an amide linkage where you have joined the boxes. Okay? Complete figure 6.2 to show the structures of two monomers needed to make the polymer. In figure 6.1, show all the atoms and all the bonds of the functional group. Okay? Okay, now let's identify the monomers by completing the diagram. Okay, I'm gonna erase all this, and now let's understand how the monomers are made. This is the first monomer, I'd say, because I have this, and around this I have this black box. I'm gonna circle all the black boxes I have. These are my black monomers. Now I'm gonna circle my, so with green color I am gonna circle out my other monomer, which is this nitrogen. So I know that my water is formed. So this is my dicarboxylic mean I have two carboxylic groups over here. C double bonded O, there must be an O and H over here. So this is one carboxylic group on this side, and I must have one carboxylic group on this side, but now I cannot see it because of the polymer formed. And this has to be an N, H, and then there has to be an other H as well. Okay, so it is dicarboxylic, and this is diamine because it has two amine groups on both sides. So for the black one, I saw it was dicarboxylic. I have to make two carboxylic groups, C double bond O, then there's going to be an O and H. This is one carboxylic group. Then C double bond O, there's going to be an O and H. This is the second carboxylic. So this is dicarboxylic. Okay. Next is going to be diamine. Diamine means one amine group over here, which is NH2. I'm drawing these two bonds as well because the question said that it wanted to see all the bonds. So this is NH2. The next is name the other product from this polymerization. It's going to be water. How do we know it? Because this H and this OH was not part of the polymer. I made it myself because I knew that water is going to be formed. That's why these were removed from the polymer. State the term given to natural polyamides. Remember that proteins are natural polyamides. Name the type of monomers which used to make natural polyamides. We make proteins by amino acids. They are the monomers of protein. Let's move on to the next question, which says one of the monomers which forms a part of a natural polyamide has 3 carbon atoms. Complete figure 6.2 displayed formula. It has to be a monomer which forms part of a natural polyamide, so it has to be an amino acid. And how are amino acids formed? You guys know amino acids have on the same carbon, or they have the on the same one monomer, they have a carboxylic group, and they have an amine group. Carboxylic group and amine group. So we have to make 3 carbons. So on this side we can make a carboxylic group. Okay, C double bond O, O and H. We can make one carbon over here. We have 3 carbons. We have completed the 3 carbons. One for the carboxylic group over here. This carbon they have given. One carbon I just drew it myself. And over here we can put our displayed formula, complete to show the displayed formula. So I guess we got to show all the bonds. So it's going to be H and H. NH2, this is the amine group I've drawn over here. In case you guys don't understand, this is the amine group. This is the COOH carboxylic group, because in amino acids we have both the amine and the carboxylic group. And over here I'm gonna open this up for you guys. It's gonna be C, H, H and H. Okay, so that is that it has 3 carbons, 1, 2 and 3, and it also has a carboxylic group and an amine group, which makes it an amino acid. ठीक है. PET is a polyester. Name the 2 types of monomers, monomer molecule needed to make polyester. Remember that in order to make polyesters you need dicarboxylic acid and diols. Okay, you need dicarboxylic acids and diols. Let's move on. Draw part of the structure of PET which shows 2 repeat units. Show all of the atoms and all of the bonds and linkages. First we're going to draw the monomers. What I said dicarboxylic. Dicarboxylic means 2 carboxylic groups, O and H. Okay, this is also going to be C double bond O, O and H. This is dicarboxylic. And now we're going to draw diol. Diol means 1 OH here and 1 OH here. Now we need to form water. In order to form water, we're going to take OH from here and H from here. Okay, this is going to form H2O. So this is removed, OH from here and H from here. So now let's draw the repeat units. One repeat unit is going to have 1 dicarboxylic and 1 ol. So now what we are only going to draw the remaining part which we have not cut out. Okay, in order to make water, we have cut 1 H from here and OH from here. That's going to make H2O. So let's draw it. This C double bond O, that's going to be a C double bond O, 1 bond extended from here. Then it's going to be this diol part, which is going to be O. This again, it's going to be O. Then after O, you're going to draw another monomer because we had to draw another repeat unit, because we had to draw 2 repeat units. This is the 1 repeat unit. You don't have to write it. I'm only writing for better understanding. Now again, no, not this one. Now we have to join it with the carboxylic part. This O with the C double bond O, C double bond O, O and O. So now we are done with 2 repeat units. This is first repeat unit and this one right here is the second repeat unit. Okay, 1 repeat unit has 1 carboxylic and 1 ol part. One other repeat unit has 1 carboxylic and 1 ol part. Let's move on. We are done with the paper. Thanks for watching my video. If you like the video, subscribe to my channel, and that's going to help the channel grow and prosper.